Okay, I'm not in class now, so hopefully this will be a little bit faster than normal. Talk about functions and how to um, kind of decipher them and how to read them. Functions are a major part of any mathematics course from now on, really. So here it goes. Functions could be increasing, decreasing, or constant, as it says here in the bold. So discuss concepts of increasing and decreasing and relative maximums and minimums. Okay, the main thing you need to know is that functions are read from left to right, not up to down, right to left, down to up. They were read from left to right. So when you see something like this would be called an increasing function because from left to right, the y values are increasing. So I'll let you read it from left, from this side to this side for that way. Those functions are increasing. No one says when we talk about functions, well, it's also decreasing because if you look at the other, no, it all follows the order of the numbers on the number line, the x-axis specifically. So this is, as um, drawn, a strictly increasing function. I'm sure you could imagine what a decreasing function looks like. And could you imagine what a constant function would look like? We'll get to that later. Um, so what if it has a little bit of both? What if it looks something like this? Well, you can see that it has some periods of some places where it's increasing, some places where it's decreasing, and I don't think there's any constant part, but there are some peaks and valleys here. Anytime you get to a top of a peak like this is called a relative maximum, or I'll usually say relative maximum, but I'll spell the whole thing there. That just means when you look around, when you look just to the left and just to the right, like here and here, just to the left and the right of that top point, it's higher than everything. It's a relative maximum. And relative minimum, I think you could see that on here. Just happened to make that on the y-axis. That's just coincidental. But that y value would be considered a relative minimum. So even though there are points that are lower, like these y values are much lower than our relative minimum, all we care about when we're talking about relative minimum is that it's lower than the points directed to the left and directed to the right of that point. So those are some basic ideas and definitions. Here is a function. Remember, in order to know that a graph is a function, it has to pass a particular test. Do you remember what that test is called? Vertical line test. Hopefully you're thinking about that. If you're not sure what it is, talk to me or another math teacher. So we're using the graph to answer the following questions. You may have to estimate some values. Okay, remember a function is just a set of inputs paired with outputs, one output per input. So for the domain, it's this set of inputs. We're looking for all the x values. The way I like to think about this is wall to wall. So I'm thinking like if I were trying to build a room around this function, where would the wall be? Like, would it be over here? It obviously wouldn't be over here because that's going right through the function. So like how far left does this function go? And because this arrow, it not only is pointing down, but it's pointing a little bit to the left, we would say that the domain of G starts at negative infinity. And does it go to positive infinity? Well, if we're looking for the other wall, you see on this side, the wall, quote unquote, that I just drew, is farther than where the function is. So the rightmost wall would be right over here where x is equal to 4. So hopefully it makes sense that the domain of G is from negative infinity to 4. Those are x values from left wall to right wall. And it's a little bit ambiguous what's happening on the right. So I'm going to put this with a closed dot just to make sure we know that it includes that 4 value. So I put brackets on there. So the range is the outputs which are associated with the y values. So that's not left and right, that is up and down, specifically from floor to ceiling. So how far down is the floor to this function? Like again, we want to just try to enclose this in a room. Well, it goes down forever. That's why the range of g goes from negative infinity. Does it go up to forever? No, it just goes up to how high? 2. Those are the y values. That's the range of g. And by the way, this is it says use a graph of g to answer. Normally, there would be something near the graph that says y is equal to g of x, just so we know that what we're looking at, the y values are a function of x, and we're calling that g of x. X-intercepts means where is a function across an x-axis, and I think we have to approximate here, but we can see normally we like these in ordered pairs, so starting from left to right, what does that look like? Negative 1.8-ish or so? 1.7? I'll say negative 1.8 comma 0. There's another one, 0, 0. That one's pretty easy to see. I hope 1.8 comma 0. And there is one more. What is that? Maybe 2.8? I'm sorry. Yeah, 2.7 maybe. It looks like a little bit closer to that middle. Y-intercept, there's only one. It looks like it is at 0, 0. Intervals on which g is increasing. Now, this is important. We start from left to right. We're talking about the x values. So it is increasing from negative infinity, and that is, I'm looking at these x values. Like down here, you can see it's this function is still going down forever. So it's increasing from negative infinity up until 1. Take a look at the y value up at negative 1, excuse me. Take a look at the y value when x equals negative 1. Do you see that that's where it reached the top of the hill, otherwise known as a relative maximum, like we were talking about earlier? So it's increasing from negative infinity to negative 1. And at that negative 1, it's actually not increasing. So that's why it's an open end right there. Is it decreasing the rest of the way? No, it's decreasing a little bit, and then it starts to increase again. I'm going to put a union in between. Starts to increase from, now we're looking at x values, 1, comma 2. And that's just right here. That 1, comma 2 is that region for those x values. In that region of x values, do you see that the y values are increasing when you're going from left to right? I really hope that makes sense. You may have to rewind this video a little bit to make sure you see that. Because once you see it, it really shouldn't be too much of a problem. Let me get rid of the stuff on here. Okay, so intervals on which g is decreasing. Well, we can see that this is a region where it's decreasing. Let me put this in green. I'm going bigger with my marks here. This is the interval where it's decreasing. We care about the x values when it's talking about the interval on which it's decreasing. So we say it's from negative 1 to 1. We just see that those y values are decreasing, but we don't name them. You're not going to say from 2 to negative 2 or anything like that. The interval is negative 1 to 1. Intervals on which g is constant. Oh, wait, is there another area where it's a region where it's decreasing? I almost missed that. There is one more. Do you already know what it is? From 2 to 3. Intervals on which g is constant, that means it's neither going up nor down. You can see that there is one interval there from 3 to 4. And I'd say maybe at 4, it's not going to go up, not going to go down. So I'm going to put a bracket on that. Number at which g has a relative minimum. Now, this number at, this is an x value. So the number at which g has a relative minimum, it looks like there's only one of those. X equals 1. Now, what is the relative minimum value? Well, at x equals negative 1, I say, okay, here's my negative 1. Not negative 1. 1, I'm going to go down. That's where the function is to negative 2. So the relative minimum value is negative 2. That's just how far it goes down. Where does that negative 2 happen? At x equals 1. So it's kind of like a what and a where. The where is x value, the what is it? So what is that minimum or maximum value? That is a y value. J, the number which G has a relative maximum. I hope you can see that there are two. Do you see both relative maximums? This should say the numbers at which, because there's more than one. So x equals -1 and 2. The relative maximum value is 2. That's how high up it goes for both of them. Now, if one would have been higher than the other, let me move this y equals g of x for a minute. You don't have to write this in your notes. But let's say that this went up like that. Then one of the relative maximums would be at 3. Sorry, one of the relative maximums would be 3, still at -1. The other one would be at 2, and that other relative max would be 2. They could be different relative maximums as long as as long as they are higher than the points just to the left and just to the right. And L, G of 3, that's just saying that 3 is the input. So what is the output when you plug in the 3? So I'm going to go to 3 on the x-axis. So my mind is here. I don't actually write this on my paper. This is for instructional purposes only. I say, okay, there's my x value of 3. Now, where does this function have a y value? And you can see that it is right down here. That y value is -1. So g of 3 equals -1. Please don't forget to rewind and to go over any of these things. And if I made a mistake, it's because I'm rushing through, but I'm trying to be as clear as possible. So if you think I made a mistake, let me know. Piecewise functions. Okay, piecewise is exactly what it means. It means it's a function that's separated into 2 pieces or 3 pieces or more than one piece. Normally functions that we've done is just one piece. It's one big function. But what we have for number 3 is a standard way of writing a piecewise function. And you can see that there are 2 parts of them here. So what I'm going to do here is I'm going to just draw the graphs first. Y equals 6x minus 1, right? I'm doing this first. Remember, f of x is basically another way to say y. So I think I can graph that. It's in the slope-intercept form, so I'm going to go down 1. I'm going to start at that -1. And from there, I'm going to go up 6, 1, 2, 3, 4, 5, 6, and over 1. And if I want to get another point from that y-intercept, I could go down 6. And to the left 1, I didn't really leave myself enough room for that, but I'm just trying to get a general sketch going in here. And you remember from geometry, for a line, how many points do you actually need to determine a line? You just need 2. Although there are an infinite number of points on that line, you just need 2 points to determine that line. So now that I have these 2 points, I can draw a pretty accurate line. And now I'm going to graph this other one, f of x equals 7x plus 3. And 1, 2, 3. So from here, I'm going to go up 7. Oh, yeah. 1, 2, 3, 4, 5, 6, 7, and over 1. Yeah, and that's the only other point I'm going to get because I just don't have a lot of space here. Now I'm going to leave these for later, but yeah, I'll get back to this in just a minute. But let me actually show you how to get right to these. I see it was asking me to graph this. It was just asking us to evaluate the function at the given intervals of the independent variable. Independent one is the one that you plug in, that's input. So if I want to, remember this is our x value. I'm going to plug that into our function. There are 2 pieces of this function. One says it's 6x minus 1 if x is less than 0, and it's 7x plus 3 if x is greater than or equal to 0. So if I'm plugging in x equals -3, that's going to go right here because -3 is less than 0. So I'll plug that in, and it says 6, it becomes 6 times -3 minus 1, which I believe is -18 minus 1, or -19. There you go. That's my answer there. Again, this is another x value, so into which piece shall I plug that in? I have to plug it into one that fits. I think this one, right, if x is greater than or equal to 0, it goes into that part of the function. So this is going to become 7 times 0 plus 3, extremely challenging to do there. F of 0 equals 3. And for C, F of 2, that 2 is our x value, so we're going to plug that into the second one, because it says the function is that second piece if x is greater than or equal to 0. So this becomes 7 times 2 plus 3, which is 14 plus 3, or 17. Again, since I boxed that first one off, I'll go ahead and box all of those. Okay, so I kind of jumped the gun with the graphs because I think that's what the next one is. So you can consider that a warm-up. Okay, here we go. Sorry about that. Graph the piecewise function and determine the function's range. Okay, so remember, range is the collection of y values, and do you remember how I told you to think about it? In terms of a room, it is floor to ceiling. I'm going to start with the second graph. F of x equals x minus 2, or y equals x minus 2. And let me change my eraser here for just a minute. Okay. So y equals x minus 2 normally looks like this. Minus 2. So slope is 1, right? There's 1 over 1 right there. So just going up 1 over 1. Wait. Okay, so then I could get a lot of points, so my line is pretty straight. There we go. So that is if we're graphing the line y equals x minus 2. But as this function says, it's only x minus 2 if x is greater than or equal to negative 1. Sorry, if x is greater than negative 1. In other words, and I'm going to just highlight which portion of the x-axis we're going to be referencing here. You don't do this on your paper. This is for just instructional purposes only. These numbers. In other words, I don't need anything that's not where those x values are. So I'm going to take my eraser and erase over here. Notice that's where x is negative 3. I don't want those. I just want this function when x is greater than negative 1. So I'm going to erase here. And what's going to happen when I get to that negative 1? Well, it's only when x is greater than negative 1. So I'm going to erase this a little bit and end there. Do you already know what I'm going to put there? An open circle. Notice I've only kept the line for which the x values are from negative 1 to infinity. So I'm going to erase that green thing because it's not part of our graph at all. It's just to show you, because I can't point to things when I'm not being recorded. It's just my voice in this drawing here. Okay, so that's the second part. But how about this first part? This f of x equals negative 3. That's the same thing as y equals negative 3. What kind of a line is that? Do you recognize it? It is a horizontal line. So normally we would graph this entire thing. Y equals negative 3 would be the whole thing. But as this piecewise function says, we're only using that line if x is less than or equal to negative 1. So now I'm going to look at this part of the x-axis, right? Less than or equal to negative 1. And I'll keep the line y equals negative 3. What's that box doing there? Okay. So that second line I just drew, this one, I'll keep only the part that's under that those x values. In other words, I need to do some more erasing. So I think this has got to go, this has got to go, and what's going to happen with this point? It used to be open circle, but I'm going to keep that from the first part of the piecewise function, right? Because x is less than or equal to negative 1. So I'm actually going to fill that in from remember what kind of function that's called? From the constant function portion of this piecewise function. There we go. Oh, it's also asking for the range. So I'm going to go from floor to ceiling. So range, let me fix my eraser here. The range, the floor of this function is -3. It includes -3 and it goes up how high? Forever. That's what that arrow is saying. That's the range. Graph the piecewise function and determine the function's range. Oh, there's something here from previous attempt. Excuse me, ignore all that. Okay. I do the easy one first. Okay, so 1/2. In my mind, I'm just like, okay. I took algebra 1 and I remember y equals mx plus b. I know that I have a point here at -3. I know I'm going to go up 1 over 2, up 1 over 2. And if I really want to do a good job and impress my teacher and put as many points there as possible, bam. Oops, that's not impressing the teacher. Okay, so there's that line. But remember, this is part of a piecewise function. So I keep this line only if x is greater than or equal to 2. Do you see which part I'm about to keep? Let's see if I can do this right. Yeah, it's everything. I need to erase this stuff here. Do you see where I'm going to stop erasing? Right there. Because that's right under x equals 2. And it says, that's what I'm looking for. I'm only keeping that line when x is greater than or equal to 2. And I'm going to make sure that I'm very, very clear by putting that closed circle at the end of that line. Or I guess it would be an array now, wouldn't it? From your memories of geometric shapes. Okay, x squared. Y equals x squared. Is that a line? We probably studied these before, but it's been a long time. So, and we haven't studied these in this class. So to graph this, my recommendation is to make an XY table. And it says when x is less than 2, so I don't want to do too much. I'm going to try to find a pattern. I'll just go from -2 to -1 to 0 to 1. Now, it says x is less than 2. Is it appropriate to plug in a 2? Maybe I should do 1.9 or 1.99, something like really close to 2. Nah, I'll plug it at 2 and then I'll remember that this, since it's not included, will be an open circle in my graph. And that's because of this. X is less than 2. So I'll notice all the numbers in my X column are less than 2. So those will all be solid. Those will be graphed. And that last one, I don't want to plug in 1.99. I don't want to square 1.99. That seems crazy. I will square 2 though, and when I put my point there, it will be an open circle. So -2 squared is 4. -1 squared is 1. 0 squared is 1. 1 and 4. Okay, plotting these. I have this. I have this, this. And remember 2 comma 4. That is an open circle. I hope you recognize what the shape this is. It is not a V. You may say it's a U. It is kind of U-ish, but you know the name is a parabola. Just like that. Then like that. It goes up forever. Okay. Does it pass the vertical line test? Let me get out my ruler. Okay, for this, just pay attention to the left side of the ruler. Let me see if I can move this a little bit. Okay, just pay attention to the left side. So I'm going to pass this vertical line through here. So it's just passing through the graph just at 1 point. Right here, still going through only 1 point. If I would have made a closed circle at the top, it would not be a function. So one of them has to be open, the other one has to be closed, or no, they just can't both be closed there. Yeah, it definitely passes a vertical line test. I know it's open up there once again because x did not equal 2, but I use that point just because again, I don't want to plug in that 1.99, but I bet if you square 1.99, it'd be just under 4. You check a calculator if you want, but that may be wasting your time. Okay. Oh, so the range. Floor to ceiling. what's the floor to this? You can see that it starts down at -2 and it goes up. Here we go again. Look at the top of this. Okay, so here's the bottom. It goes up. Okay, there's y values there. There are y values there. There are lots of y values here. How far do they go up? Oh, do I have to stop there? No, they continue up. You can see it both on the parabola and the line. They continue up forever. So that is the top of the range, -2 to infinity. Okay, moving on. Oh, not moving on. Well, we've come to the end of this lesson. I hope it made sense. Rewind it and replay if something didn't, and make sure to come see me if you have any questions. Thank you.